All right. Section 7.7 is application problems, and I know that's everybody's favorite. So we are going to be doing the same applications problems that we did in chapter 4. No, sorry, chapter 2. But this time we're going to use two variables instead of one. And so when we have two variables, then we are going to do two equations, and we are going to use systems to solve. All right, so giving you a heads up, guys. I love this question more than I can tell you. I love to put it on homework. I love to put it on quizzes. I love to put it on tests. You will see this problem a lot this year. So just kind of a heads up, make sure you know how to do this type of problem. Rectangular soccer field has perimeter of 360. That should be a rectangle. Its length is 20 yards more than its width. So we have length and we have width. And we're going to call length L and we're going to call width W. So this is different from how we did it in the past, okay? The way we did it in the past, we only used one variable and we said whichever one was not described, that's the one that gets a variable. This time we're talking about two different things. We get two different variables, okay? But because we're using two variables, that means that we need two different equations, okay? So the first equation is going to come from this perimeter here. So we know that the perimeter is equal to my length plus my width plus my length plus my width, or if you can remember the formula, 2L plus 2W, okay? And the perimeter, they told us, was 360. So right now I have 2L plus 2W is equal to 360. Then they also told us that the length is 20 more than width. 20 more than width. So my second equation, and this is set up for substitution because I have L equals. You can use either substitution or elimination when you're solving these systems, but this one is set up for substitution. So we're going to substitute in for L. So I'm going to substitute my 20 plus W. And distribute. One thing that I find is that students, for some reason, only ever add the width plus the length and then they stop. Make sure you go all the way around. You need two L's and two W's and not just one L and one W. And we're going to subtract our 40 is 320 and I get 80. So 80 yards. Okay. Then we're going to take our 80, we're going to plug it into one of our original equations. I would probably do this one right here. So L is equal to 20 plus my W is 80. And so I end up with 100 yards. Okay, like that. All right, I always kind of liked these problems because they are pretty straightforward. It's pretty easy to find the equations. So for the 2013 Major League Baseball and National Football League seasons, based on average ticket prices, 3 baseball tickets and 2 football tickets cost, so 3 baseball and 2 football cost $245.52. And then 2 baseball and 1 football cost $136.50. Okay, so B would represent the baseball ticket and F would represent the football ticket. This one is set up for elimination. So what we're going to do is we're going to multiply the bottom equation by -2. I think I actually have, yeah, some room on this slide. Okay, so we're going to multiply the bottom equation by -2 so that I can eliminate my F. So 3b plus 2f is equal to 245.52 -4b minus 2f. And I can't do that in my head. Times 2 is -273. And then I'm going to add these together, and my f's will cancel. And 245 is -27.48. And then divide by -1. And a baseball ticket is going to cost $27.48 average. Okay, I'm going to take this, I'm going to plug it into one of my original equations. I will probably use this bottom one. Hold on, there we go, bottom one. So 2b plus 27.48, 136.50. Subtract my 27.48. And I did that completely wrong. I think my brain's going dead. All right, try that one more time. Sorry about that. My B is 27.48, not my F. 27.48. You guys are supposed to catch me on this. F is equal to 136.50. There we go. 54.96. 136.50 minus 81.54. Probably should have stopped with the last section. My brain's getting a little tired there. All right. Mixture problems. You guys remember the mixture problems? That was when we had the buckets. Remember the buckets? So we have a grocer has per pound, guys, per pound. That means this is a rate. We've done mixture problems before where they were per cent. This is per pound. This is a rate. It goes underneath the bucket. And $8 per pound. We don't know how much of this, and we don't know how much of this. $8 per pound. And she will mix it to make 50 pounds at $5.60. Guys, there will be a mixture problem on the test. There will be a mixture problem on the semester exam. So learn how to do it. It's not that hard. Okay, so we need two equations. If we have two variables, we need two equations. So the first equation is going to come from here. So amount plus amount is equal to amount. X plus Y is equal to 50. And then the second equation, remember how we multiplied these? So 4 times X plus 8 times Y is equal to 560 times 50. So I'm going to go ahead and multiply that. 5 times 50, 280. All right, so X plus Y is equal to 50. This one is 280. Pick your preference, whether you want to do elimination or substitution. This would be pretty easy to solve for one of the variables. I'm probably just going to do the let's do substitution. So we're going to subtract x. Let's subtract x. We're going to subtract x. Okay, so we have y is equal to 50 minus x. I'm going to substitute this into my equation. So 4x plus 8y, but I'm substituting the y as 50 minus x is equal to 280. And I don't trust myself anymore. I'm going to use a calculator. 400 minus 8x. This should probably be my last video of the night because I'm tired. Negative 4x, and I'm going to subtract 400. So 280 minus 400 and divide by 4, negative 4. And I get x is equal to 30. So 30 pounds. And remember, the total has to be 50 pounds. So x plus y is equal to 50. So if my x is 30, that means my y has to be 20. And distance, rate, times problems. So remember, distance is equal to rate times time. Or if it says something along the lines of time is the same for each, distance divided by rate. So a train travels 600 miles. And my time is going to be distance divided by rate. Same time. That's why we knew to use this. Truck travels. This is my distance. And so my time over y. Okay. And then find the speed of each vehicle if the train speed is, so my train, x is 8 faster than the truck. 8 faster than the truck. Here's my truck speed. And then I also know that the time is the same. The time is the same. So this has to equal this. So 600 over x, time is the same, 520 over y. So these are my two equations. Let's see if I got it. Let's see. Okay. So what I'm going to do you guys remember proportions where we cross multiply? Cross multiply. So this is going to give me 600y is equal to 520x. And that should look similar to how we have it over here. Do I have it similar to this? Okay. I had it like this. I had 600 y is equal to 520x. And so what I did was I subtracted 520 from both sides. 20x. And so that's this right here. And then did I have the x is equal to y? Oops, wrong way. X is equal to y plus 8. All right. So what I'm going to do is I am going to take, to be completely honest, I like it set up better this way. 600y is equal to 520x. And I'm going to substitute right there. So 600y is equal to 520. I could have done it either way, I guess. Distribute 520y plus no idea what that is. 520 times 8, 4160. And I'm going to subtract. And I get 80y Let's hope that divides evenly. And it should. I get 52. If my y is 52, then my x has to be 52 plus 8, which is going to give me 60. So let's make sure we have answered the question. We got x is equal to 60, and y was 52. All right, and yes, the train is going faster than the truck, which is what we would expect if the train goes 600 miles and the truck goes 520. All right, upstream, downstream. You guys remember your upstream, downstream problems? When we're going upstream, we have to subtract off the current to make it, to slow us down. And when we're going downstream, it's going to speed us up, so we're going to add the current. Traveled 30 miles upstream in 5 hours and 3 hours downstream back to the spot where she started, so she's going the same distance both ways. Find the canoeing rate in still water. Okay, so remember, rate times time equals distance. So rate times time is equal to distance. How do we have it? There we go. So we have rate times time is equal to distance. Rate times time is equal to distance. Now we can actually distribute, but I want to show you something. Do you see this is a 5 and this is 30? If I divide both sides by 5, this is just a little trick right here, that will cancel the 5s. And I get x minus y is equal to 6. Can do the same thing with the 30. You can't always do this. You just have to check to see if the numbers go in evenly. And by doing that, then it's already set up for elimination. We have 2x is equal to 16, or x is equal to 8. And then let's plug it in here. 8 plus y is equal to 10, so y is equal to 2. Let's double check, make sure. 8 miles per hour and 2 miles per hour. All right,